In this video, we are going to learn inverse propensity score weighting with a demonstration of SPSS. And data set and we have is the same data we've been using for propensity score analysis lecture in analyzing effect of SLE to the coronary classification. And we have this many potential confounders, as this study is a cross-sectional study and there is no randomization happen. And so first few minutes, and let's review logistic regression creating propensity score. And we already went over this in the previous video, but I'm repeating it again. So here is the data set. And the main analysis we perform is, here is the data set. So we are going to analyze the effect of SLE on the coronary classification, coded as 0 and 1, and we have 1, 2, 3, 4, 5, 6 potential confounding variables. We actually do have many more, but for this video, and we are limiting to only 6 covariate. So the first analysis we perform is to use logistic regression. So we go to regression and binary logistic, and to create propensity score outcome variable for logistic regression is SLE, and we put potential covariates in here. Okay, and then we click on the save button and to click predicted probabilities. This way SPSS will allow us to save a predicted probability in the working data set. Predicted probability at propensity score. Okay, and we go back to working data set, and let's make sure propensity score is created, which is right here. And I'm going to rearrange this to the top of the data set. Okay, so the next, and we are going to create inverse propensity score weight. To do that, we go to transform compute variable, and let's put the name for the weight, and we call it weight. And weight would be inverse of propensity score for a person with SLE. So we need to put condition on it by clicking if. So we put SLE equal 1. Okay, and then run it, and let's check if the variable is created. So it was created here, although of course that is only for SLE. So we have to repeat this for non-SLE patient. So we go back to compute variable, and then we put 1 over 1 minus propensity score. Propensity score for the non-SLE patient would be a probability of not having SLE. That's why we have to put the 1 minus here. And we change this to 0 and then continue. And OK. So this should create weighting for all patients. So what the weighting does is to inflate a number of sample size. So what it does is, usually in SPSS, one line is considered as one patient, and although when you look at ID number 1 patient and weight is 2.4, so you count this person as having 2.4 people rather than 1 person. And same thing here for ID number 2 person, and you count this person exists as 2.23 people, not the 1. Let's look at ID number 51 patient, and then this person does have SLE, and propensity score is only 17.5%. And what this means is this person looks like very unlikely to have SLE, but it does have SLE. So those populations are small, right? So we actually do count, inflate more for these. Okay, so this person, ID number 51, is counted as having 5.69 people rather than 1 person. And same thing, if we go to non-SLE patient and non-SLE patient, and actually ID number 108, and this person is very likely having SLE, but it doesn't. So this is in fact the rare population. We count this person as having 6.6 people rather than one person. So by doing this inflation, and if we count total number of patients and if we evaluate the balance, and this inflation will allow baseline characteristics equally balanced between two groups. So this is how the inverse propensity score weighting method does count for potential biases. Okay, enough talking, and let's go back to regression. And now we are performing outcome regression to analyze effect of SLE on coronary calcification. Many of you might have already noticed we inflated sample size. So inflation of sample size make p-value too small. So inverse propensity score weighting method, we do have to use a little more advanced statistics to adjust this inflated sample size to the original, to get the same as original sample size. To do that, then we are going to use little more advanced statistics called a robust method to calculate variance and covariance. And options in SPSS to do that is a generalized estimating equation. So you go to generalized linear models and get the second choice. Okay. So this is GEE, and I will show you quickly how to use GEE. In this application, subject variable would be ID, and you go to type of model, and outcome variable. Outcome variable is binary, so we click binary logistic, and response would be calcium. So this is outcome regression, so we use calcium. When you specify binary outcome variable, and SPSS want to know what would be the reference category. So let's pick first here. Otherwise, if you forget, an odds ratio would be inversed. And then go to, actually one more thing, and most important in this, you need to specify weight to the scaled weight variable. And so this way, SPSS will count number of persons accordingly with the number specified by weight variable. So you go to predictor, and predictor would be SLE, and let's put the option of descending for SLE. This way, odds ratio will have a denominator of non-SLE person, and numerator would be SLE person. And that's it for predictor. And go to the model, put SLE and statistics, and click here so that you don't have to use calculator to convert beta coefficient to odds ratio. And that's it. And if you click OK, and now you have adjusted odds ratio of SLE compared to non-SLE on having coronary calcification is 4.899 with a p-value of 0.004. So this is it for inverse propensity score weighting method.